So we learned about the particles that are in an atom. Now we need to look at how are those things structured to make a specific atom, right? So the subatomic particles of an atom are arranged in specific positions that this is the atomic structure of an atom, right? So you learned before that protons are in the nucleus, neutrons are in the nucleus, and then that electrons are like outside, right, in this electron cloud. Okay. While there are more precise drawings of the atom, the easiest way to draw is to draw it like Niels Bohr did in 1913, which resembles a solar system. You have the nucleus in the center, that's where our protons and our neutrons are. And then our electrons live in shells outside of the nucleus. Okay, so Bohr's model of the atom shows the nucleus at the center, which houses all of the protons and neutrons. The rings around the nucleus are shell-like and are called energy levels. There are 7 of these energy levels, 1 for each row of the periodic table. Electrons are housed in the energy shells with specific numbers of electrons filling into specific energy levels. So, for example, energy level 1 has 2 electrons. It can't have any more than that. It has to have 1 or 2 electrons. Okay? And then when you get up to the next level, you have to have this first level full. Then you can fit up to 8 electrons in that next level. Once you hit 8 and you want to go up, then you have to go up a level. And so level 3 has 18 electrons in it. Okay. 4 through 7 are a little more difficult than that, so we're not going to cover those. But you do need to know the arrangement of the electrons in the first, second, and third energy levels. Okay. So now let's look at those electrons. The electrons in the outermost energy shell are called the valence electrons. Okay, so we looked at 1, 2, and 3. If the next one only has 1, then it has 1 valence electron. In the periodic table, for common elements, the number of valence electrons corresponds to the group number. Okay, so for example, sodium would have 1 valence electron. Magnesium would have 2 valence electrons. Then if you skip over those transition metals, the like aluminum would have 3 valence electrons. Silicon would have 4 valence electrons. Phosphorus would have 5 valence electrons. Sulfur would have 6 valence electrons. So that means that there are 6 electrons in the outer shell. Okay. And then chlorine 7, argon would have 8. And again, if you look at the second row, or sorry, the second shell, that shell can only hold 8. So normally 8 is the most. It's the number of valence electrons that feels good to the atom. Okay, it's its favorite number. Okay, now I want you to add these numbers to the top of your list, right? So if you pull out your periodic table, I want you to write number 1, 2, 3, 4, 5, 6, 7, 8, right? On the top of the rows or top of the groups. All right. When we want to draw a Bohr model atom, so let's say that we're going to do a lithium. Okay. Lithium has 3 protons. Okay. And if it's lithium 7, it has 4 neutrons, right? So this is our nucleus, right? We're showing that it is lithium and we're showing that it has neutrons, okay? In the center of the atom, you write the number of protons and number of neutrons. You don't have to do the circles or anything like that. You just have to write them this way, all right? Then you have to draw the correct number of energy levels, right? How many circles should go around the outside, okay? Then you're going to draw dots to represent the electrons, right? So in our first shell, you can have 2. It doesn't matter where you draw them as long as there are only 2, right? Then when we draw the second energy level, right, you can have up to 8, but in this case, I'm only going to have 3 because all of my atoms are going to be neutrally charged, which means they're not going to have a charge, okay? So you should now be able to draw and explain the structure of the atom, and including the arrangement of the subatomic particles like the protons, the neutrons, and the electrons. Okay?